Today I want to talk to you about something that really motivates me every day and sort of guides what I work on and inspires me. So to ground this a bit more, I want to share some observations about the current state of software development. So this graphic you've probably already seen before. This has been standard fare in all data science talks for the last decade. But this graphic is Monica Ergotti's data science hierarchy of needs. It does a good job of listing a lot of the tasks, common tasks that people do in a machine learning or data science workflow. And one observation that I want to make is we need to write code at all stages of the workflow. It doesn't matter if it's AI or deep learning or cleaning data, we end up writing code at all these stages. And writing code is central to everything we do. But our tools, the innovation in our tools have mostly focused on the outer loop. How we write code has mostly stayed the same for a long period of time. Whereas there's been a lot of innovation in sort of the data and compute layer, also what I call star ops, which is like ML ops, data ops, whatever you want to call it, things that help you bring things into production. There's been a lot of innovation around that. And as you move your code into production, it's well known that friction rapidly increases when repackaging that code. So we live in two worlds. Basically, a lot of people start off in a kind of a REPL or a notebook. They write code there and end up refactoring it on the path to production. But you also end up refactoring code the other way. If you need to play with your code and experiment with it when it's already in production, a lot of times you end up refactoring parts of your code in a way that you can play with it in a notebook and a REPL again. And we live in these two worlds. And this is a well-known kind of thing, and it's something that we debate a lot as a community, to the extent where we debate how we write code. I think kind of this is really well illustrated by the way Joel and Jeremy kind of debate each other. I don't like notebooks, and I like notebooks, kind of two extremes on the same spectrum of how we write code. And kind of a more recent data point is there's this excellent study done by Shreya Shankar and her colleagues from UC Berkeley called Operationalizing Machine Learning. And over the course of several years, she canvassed the industry and collected best practices and kind of took notes on the hurdles that people faced in their pain points in their workflow. And the thing that stuck out the most is this contention about how we write code. Particularly, there was a lot of strong opinions on Jupyter Notebooks that were wildly different. So just to highlight some anecdotes, so some participants preferred to use notebooks in production, and I'll read one anecdote from an interviewee. So we put each component of the pipeline in a notebook, which has made life so much better. Now I can run one specific component if I want, not the entire pipeline, so on and so forth. And kind of an opposing anecdote that another interviewee says, we even went as far to philosophically discourage the use of notebooks in the development environment altogether. So that's profound. Those are really diverging viewpoints in applied machine learning teams. And so this is summarized in the paper saying that, okay, this kind of conflicting opinions is because of competing priorities. And those priorities are either moving at high velocity or kind of reducing bugs and things that can be reduced by imposing more constraints on the development environment. So are we left with just debating this forever? Are we going to be left? Is this an impasse where we just have to live with in terms of how we write software? And I don't think so. I want to kind of tell you about two very interesting threads in programming that I think are really exciting and offer a lot of possibilities, and also show you some examples. So these two threads are literate programming and exploratory programming. And I'll talk more about what these two things mean in a bit. So to help illustrate these two things, I'm going to lean on kind of two champions of these various paradigms. One is Donald Knuth for literate programming, and one is Brett Victor for exploratory programming. So I'm going to first tackle literate programming. So literate programming is an idea that combines programming and documentation. And the idea is that software is written to be read by humans, and it's natural language interspersed with code. The person who coined the term literate programming is Donald Knuth. He's kind of most well known for his encyclopedia on algorithms called The Art of Computer Science. And that's what most people know Donald Knuth as. But I argue a lot of people don't know Donald Knuth. I'm going to get to that in a bit. And even if you don't know Donald Knuth, he's probably touched your life in one way or the other. If you've ever done a whiteboarding interview, algorithms interview, if you've been hazed in this way, you can almost draw a straight line between that and this encyclopedia of algorithms. And it's really this encyclopedia of algorithms is one of the most celebrated works in computer science. There's notable people in computer science that have said really good things. Like Bill Gates has said, if you're a really good programmer, read Knuth's book. You should definitely send me a resume if you can read the whole thing. Peter Norvig has said, the art of computer programming is the Bible of its field. Like an actual Bible, it's long and comprehensive. No other book is as comprehensive. That's ridiculously high praise. And again, this is what most people know Donald Knuth for. That's what people associate with him. And it's really interesting because they also associate Donald Knuth with this ideal of like rigor of computer science. But the lesser known part of Donald Knuth is this term literate programming. And I would argue that Donald Knuth is even more excited about literate programming than this encyclopedia of algorithms. And there's this excellent book where he's compiled all of his papers and all of his talks on the subject, which I'm going to go through some excerpts in a bit. So Donald Knuth actually, it's really interesting to look at the workflow of Donald Knuth. Like, how does he program? What does he do? And he's actually developed his own programming language that is a literate programming language, and it's called Web. And he programs in one, it generates source code from one source of truth. Source code and documentation from one source of truth. So he writes his code in prose in one place, and that compiles to a program, and it also compiles to documentation. And just to kind of walk you through a little bit more about how important this is, I'm going to kind of go through some hot takes from Donald Knuth on literate programming, which I think are really interesting because they are really hot takes from someone who is very mildly tempered, normally. So I'm just going to read these off. Let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer on what to do, let us concentrate on explaining to humans what we want a computer to do. So that should tickle your brain a little bit, explaining to humans what we want a computer to do. That ties into some of the recent kind of AI-assisted code development, which I'm going to touch on later. He also says, by coining the phrase literate programming, I am imposing a moral commitment on everyone who hears the term. Surely no one wants to admit to writing an illiterate program. All of the major problems associated with computer programming are ameliorated when programs and their dialogues with users become more literate. That really floored me when I saw that. I read that at least 20 times to make sure that was the quote. Programming is best regarded as the process of creating works of literature, which are meant to be read. And then the last quote, in retrospect, the fact that a literate program takes much less time to debug is not surprising because the non-literate program encourages discipline, the literate program web encourages discipline I was previously unwilling to impose on myself. There's actually one more quote, sorry. And that quote is, he has found to his surprise that the total time of writing and debugging a literate program, which is this web program, is no greater than total time of debugging a non-literate program, even though his literate program are much better and have substantially more documentation. So this is really interesting. And he lives in a different world, a different workflow that few people experience. And I want to point out that this literate programming paradigm is very experiential. Like, you only can understand it if you experience it. But the tragedy is that not this web language is not something that is accessible to a lot of people or practical for a lot of people to use. So not that many people have really experienced it and kind of can only read about it through these works from Donald Knuth. And Donald Knuth hasn't changed his mind. If you look at recent interviews with Donald Knuth, he goes on and on about how great literate programming is. I would say, that he really lights up and is very excited when he talks about that. And so now that you understand what literate programming is, we have seen nods to literate programming in a lot of places. So things like R Markdown, where you can weave together code and prose together. And then notebooks in general have been a nod to literate programming. Things like MATLAB, Jupyter, Mathematica, where you can write code and prose together. But writing prose and code in prose with production code is still painful. So this is scikit-learn documentation. So you see the right-hand side of the slide, that's a page from scikit-learn documentation. It looks like a notebook, doesn't it? It has what looks like a cell that runs some code, has some documentation, but all of this is stuffed into a string. And that's really painful. And there's still a gap with literate programming. Notebooks don't really take you all the way. You still have to refactor your code out of the notebook to create a program. So it's not really like anything like web, where it's a single source of truth that generates both documentation and source code. There's still a gap. So I want to switch gears a little bit and talk about exploratory programming. So exploratory programming is the idea that you should have an immediate connection and feedback to your code. It really focuses on interactive and dynamic development. And the best champion of exploratory programming is Brett Victor, I would argue. Brett Victor said he wanted to make a new MATLAB, or a cross between MATLAB and GarageBand, which I hope he does work on one day. So I'm going to show you, one of the best talks on exploratory programming is this talk from Brett Victor, Inventing on Principle. And that talk is very long. I can't show the whole thing, but I'm going to show you 2 excerpts from that talk that really highlight why exploratory programming is useful. So hopefully the sound can play.
So down here I've got this for loop where I'm counting to 16. I'm putting 16 little pink blossoms on every branch. And I can turn that down for less blossom or turn it up for more. But look at what I'm doing here. I'm just kind of moving that number up and down around 20 or so. And it has this really interesting shimmering effect. It kind of looks like the wind is blowing through the tree. And the first time I saw this, I immediately started thinking about how I could use this effect for an animation. How would I ever have discovered that if I had to compile and run between every change? So much of art, so much of creation is discovery, and you can't discover anything if you can't see what you're doing.
So that's really profound. So much of creation is discovery, and this exploratory programming paradigm is important to that. Here's another demonstration where Brett Victor goes through kind of a video game demo of a similar idea.
And now I can try it, but now it's not bouncy enough. And so while it's nice that I can kind of adjust the code while it's running, instead of having to stop and recompile and find my place again, I can't immediately see what I need to see, which is whether or not he can make that jump. So here's what I'm going to do. I'm going to bounce off my turtle, pause the game, and now hit this button here, which shows my guy's trail. So now I can see where he's been. And when I rewind, this trail in front of him is where he's going to be. This is his future. And when I change the code, I change his future. So I can find exactly the value I need, so that when I hit play, he slips right in there.
So yeah, this is really interesting as well. I would say a lot of hacking on machine learning and data cleaning code feels exactly like this, doesn't it? And it's really important to that workflow. And Brett Victor just does a really good job of explaining the concept to a much broader audience. So now that you understand a little bit about what literate programming is and what exploratory programming is, what if we combined the two concepts together? What would that look like? And so that's what nbdev is. nbdev is a Python project that allows you to write literate and exploratory programs. And it's kind of supercharged with notebooks. And so what nbdev does is it extends notebooks, and it makes them overlap a lot more with literate programming and exploratory programming. It just extends notebooks to do a lot more. So what is nbdev? So at a high level, this is not an nbdev talk, and I have separate talks on nbdev, but I'm just going to give you a lightning version. So nbdev allows you to generate Python modules from notebooks. There's a two-way sync between your notebook and an IDE. And you have fine-grained control on like what cells get exported, what cells don't get exported, so on and so forth. You can develop your modules directly from notebooks. You can import modules into other notebooks. The documentation is automatically rendered with Quarto. And you might remember Quarto if you were in this track earlier today, and JJ Allaire, who's sitting right there, demonstrated it. It's a beautiful project, by the way. You can even write your README in notebooks. There's also a unit testing framework that works in CI, and it works out of the box. And there's facilities for Python packaging. And so it is a system for literate programming and exploratory programming that is accessible to a lot more people because it uses it's for a very popular very popular programming language. This is Python. And it just means that a lot more people can experience what literate programming is and what exploratory programming really is. So the results, the project has enjoyed lots of popularity. It has been used to write significant Python projects and libraries. So FastAI, one of the most popular high-level libraries on top of PyTorch for deep learning, was developed using nbdev. The most popular Python client for the GitHub API, called GHAPI, is also developed with nbdev. So it's not just about data science and deep learning. It could be used for kind of general purpose programming. And there's a lot of people that really like nbdev. This is a quote from Chris Latner, who's the inventor of Swift and LLVM, who says he really thinks nbdev is a huge step forward in programming environments. And this is kind of one anecdote I'd like to throw out there to help illustrate what nbdev is. So this is Eric from Lyft, and he says, I use this nbdev in production at my company. I can write docs, test, and code all in one place. I get a lot of skeptical looks when I say the source code is in notebooks, but that's just syntactic sugar for the source code. So what are the challenges with nbdev? I want to share like some things we learned. So kind of three main pain points is the source of truth isn't plain text. It's a notebook. So diffing on GitHub is hard. And that can be difficult for some people because you can't install plugins like nbreview or something like that. Not everyone can install those plugins. It's also effectively a new programming language in some sense. Because it offers a new workflow, you kind of have to think about your workflow differently. And then also it's bootstrapped with notebooks rather than being an IDE built from the ground up. So there's some rough edges and limitations. But I think one of the things that kind of limit nbdev is that we get caught up on debating about notebooks. People see the word notebooks and they debate the word notebooks. And kind of, I think that's the wrong thing to be doing. I think we should see the forest for the trees. So there's these concepts that we learned about today: literate programming, exploratory programming. And literate programming, exploratory programming are not synonymous with Jupyter notebooks. We can innovate on notebooks. We can have a new kind of notebook. We can use something else that's not notebooks. We are empowered to make tools in this space. These ideas, I think, are more important now than ever. This is a demo from Greg Brockman from OpenAI. I don't know if maybe you've seen this demo where he uploads a video file into ChatGPT, and using kind of the alpha plugin that has access to a Python interpreter, he says, can you extract the first 5 seconds of video? And then ChatGPT generates the Python code, but also executes it. And we also see people starting to make plugins in their notebook where they can converse and get assistance with AI. And this kind of conversational, kind of literate, exploratory mode is very important. And it kind of fits the UX of this kind of AI-assisted coding. And it really pushes this paradigm forward a bit more. So, okay, my call to action here is, I think there's lots of room to build tools upon these concepts. Again, it's not just notebooks. I think we can think outside the box. We don't have to get stuck in notebooks just for analytics, or notebooks just as hosted collaborative environments. It's not only about notebooks. And I would say very few people are working on this problem. And yeah, if this is something that interests you, if you're curious about the future of nbdev or what I'm working on, what we're working on, I would love to talk to you. And please get in touch. Thank you.